Welcome to Brain Vision.
So the angular speed of the pulley is related to the speed of the masses. We can say that omega would be equaling V over R. And so we can apply the conservation of energy. Energy initial equals energy final. And we can then say that we know that all objects have an initial speed of 0. So we can say 1/2 m sub a v initial squared. This would be the initial translational kinetic energy of mass A plus the initial translational kinetic energy of mass B plus the initial rotational energy plus the initial gravitational potential energy plus the initial gravitational potential energy of mass sub B. Rather, we can say mass sub 2I, and then here we can say y sub 1I. And this would be equaling essentially the exact same thing, but final. So it would be 1/2 m sub a v final squared plus 1/2 m sub b v final squared plus 1/2 I omega final squared plus m sub a g y sub 1 final plus m sub b g y sub 2 final. And so we essentially find that mass, we can start over here, mass sub b g h would be equaling 1/2 m sub a v final squared plus 1/2 mass sub b v final squared plus 1/2 times 1/2 m r squared multiplied by v final over r quantity squared plus m sub a g h. And so we can say that v final would be equal to the square root of 2 times m sub b minus m sub a times gh. This would be divided by m sub a plus m sub b plus 1/2 times the mass of the pulley. And so we can then solve. The final velocity would be equaling the square root of 2 times 38.0 minus 35.0 kilograms multiplied by 9.80 meters per second squared multiplied by 2.5 meters. And then this would be divided by essentially 38.0 plus 35.0 plus 1/2 times 3.1. The units are, of course, kilograms. This is equaling 1.4 meters per second. This would be our final answer for the final velocity. That is the end of the solution.